Alright, good evening. So today we move on to the third locus, the third type. So previously in our previous video, we actually saw two types. One is locus of a circle, okay, a point which is moving from a fixed point, okay, with a constant distance, that's one. The second one was a perpendicular bisector, whereby a point that moves, which is always equidistant from two fixed points. So we actually get a perpendicular bisector. So today we move on to the third kind of locus, third type. Okay, now what happens if a locus of points that are constant distance from a straight line? So the key words here are constant distance from a straight line. Okay, are straight line parallel? They form straight lines which are parallel to the original straight line. Okay, so for example, now let's say I've got AB. Okay, so they want you to draw the locus of a point P such that, okay, it is always equidistant from the line AB. So now let's say this is my line AB, and I've got a point P which is actually moving, which is about okay, which is about 2.8 cm on both sides of the line. Okay, so when you measure here and when you actually measure here, okay, the points are about the same. So now what happens is when you actually connect, that means this point is actually moving constantly above and below the liner. So because we want this distance which is actually the same, so what happens is when we actually connect, you actually get two lines which are actually parallel to the original straight line. So these are the two parallel lines formed, okay, above and below the line of AB. So this becomes my locus of P, and this is again my locus of P. So they actually form two parallel lines above and below the line AB. Alright? Okay, so that's one. Okay, the next one will be the last one. Okay, so this is the fourth kind of locus. A locus of points that are equidistant. This is again equidistance from two intersecting lines. From two intersecting lines is the angle bisector, okay, of the angles formed by the intersecting lines. Okay, so this is actually an angle bisector. Okay, so what they're trying to tell you is, example, let's say I've got two lines, PB and PN. Okay, they want us to construct a locus of point P such that it is always equidistant. Okay, such that it's always equidistant from the straight line PQ and PN. Okay, the intersection is at P. That means my angle is here. Okay, so for in this case, they are saying it is an angle, it's an angle bisector. Okay, so what you do is, okay, we do this. So one here. Okay, one more here. Okay, so now here when you actually connect, okay, so this is your locus which actually divides the angle into two equal parts. Okay, so this is your locus of P. So this is your locus P. So this becomes the angle bisector for the angle QP. Okay, so this is the fourth type. So I just run through. The first one was a circle, locus of a circle, one fixed point, one moving point. Okay, the second one was a straight line, a perpendicular bisector, where one point is actually moving equidistance from two fixed points. Okay, and the third one is this. The third one is whereby you have a point moving equidistance above and below a straight line, a straight line which is AB. So what we actually get is two parallel locus above and below. Okay, and the last one is a point P which is actually moving and is always equidistant from the line PQ and PN. So what happens is this forms a angle bisector. Okay, so altogether there are four types of locus that you can actually get, okay, using certain constraints in this chapter. Thank you.